This is just a real simplistic proof of the sum of a geometric series, but I wanted to commit this to a video just in case you needed to ever see it or needed to remember it. Let me just take you through this. So this is saying we have a geometric series, and notice it has a common ratio of r. Okay, so the ratio is right here. It's being raised, in this case, to the n minus 1. Now that's just notational. It's really not going to make a big difference, but it makes the proof look a little bit easier. You can see that I'm starting at 1, so the first term is going to be r to the 0, and you can see me listing terms out here. So I have this multiplier. Okay, first term, of course, anything to the 0 is 1, so the first term really is just this constant multiplier, but I'm listing everything out. Okay, so this is a geometric series, okay, with a ratio of r. S represents the sum. Okay, so assuming it's a convergent series, it's all going to add up. If I could actually add up all the infinite terms, I would get S. So here I just started by listing some terms out. Here's the first term, 1, 2, 3, okay? Now, I have factored an r out of every term. Now, of course, here there really wasn't an r to factor, so it ends up as r to the negative 1. But here I factor an r out, I have r to the 0. Here I factor an r out, I have r to the first, and so on. Now, what I want you to notice is right here, and going on to infinity, and remember, it's an infinite number of terms, so cutting one off at the end, really, it doesn't matter. Infinity minus 1, infinity plus 1. And why I say that is because look at what up here I've said S was equal to. Well, if S is equal to a times r to the 0, a times r to the first, this thing here is S, so I can replace it. And you say, yeah, but you cut a term out. Right, but it's an infinite number of terms. And cutting out one term out of an infinite number, I still have an infinite number of terms. So it's really playing with the idea of infinity here. So I replace this with S. So I have the initial times S. Now I multiply r back in, okay? And I have that. Now, at this point, I actually kind of skipped a step when I wrote this. I brought the s's together. And then I factored an s out. So you can see I factored an s out. So the sum, remember I was trying to figure out what the sum was, I just divide. So the sum is this first term, a naught, divided by 1 minus the ratio. And that's the sum of a geometric series. So it really plays with the idea up here of infinity, but it's actually a pretty nice, easy proof.